Hello, everyone, and welcome to the April edition of the Professional Advancement Workshop Series, or PAWS. These workshops are here to give you training that is beyond your standard scientific research. And these are geared mostly for graduate students and postdocs, but everyone is welcome to participate. My name is Jessica Noviello. I'm the organizer and also the Nexus NASA Postdoctoral Management Program Fellow, which is quite a mouthful. Before we begin, I just have a couple of standard details to go over. First, we are using Zoom for this meeting, so please keep yourself on mute during the presentation. And on the, if you want to interact, there's the chat button. There are lots of reactions on the bottom of your screen. And if you'd like to ask a question, feel free to hit the raise hand button and I will call you and make sure that you can be unmuted. Second, I want to remind everyone that there is a code of conduct in place for this and every PAWS session. I will put the link to our code of conduct in the chat in just a moment, but these events are meant to be for everyone to come and learn from each other in a safe environment. So if you ever feel like you need to talk about something, feel free to reach out to me or to Sean Donegal-Goldman or Melissa Kervin-Brooks to talk about it with us. So thank you once again to the NASA Astrobiology program for sponsoring these events. So today we are so lucky, I'm really excited myself to hear from some team members of Universe Sandbox. Universe Sandbox is a top-rated physics-based space simulator. It merges gravity, climate, collision, and material interactions to reveal the beauty of our universe and the fragility of our planet. Dr. Erika Nesvold is an astrophysicist and a developer at Universe Sandbox, and Dan Dixon is the creator and founder. Both of you, thank you so much for being here. We are really looking forward to our conversations. And I will cede the floor to you now for your introductions. And Erika, would you like to start us off?
I would be happy to. You just want our backgrounds, basically?
Yeah, just anything you want to say.
Thank you, Jessica. Thanks for having us. So I did a PhD in astrophysics at University of Maryland, Baltimore County, which meant I really did it down the road at NASA Goddard. Then I did my thesis on dynamics and debris disks, exoplanetary debris disks, and collisions in debris disks. And then I went off to a postdoc fellowship at Carnegie DTM, which is no longer DTM, but the Carnegie that's in Washington, DC. And in the middle of that, I realized that my two-body problem was making the geographic inflexibility of my career kind of annoying. And I went looking for industry jobs that would let me be more geographically flexible. I also realized I hated writing grant proposals, but I loved the work that I did. And so I was really delighted to find a job posting for this job I have now with Dan, which was to basically do the kind of dynamic simulation work I was doing in my research, except Dan would pay me to do it and someone else would do the graphics and the user interface. And so I went to work with him on Universe Sandbox and essentially being one of their astrophysicists doing the scientific simulation part of the game, because it's sold as a video game, but it's very important to all of us to make it based on real physics so that as you're playing around and interacting with it, you know that the physics is based on reality. And I've been doing that for 4 years now. One of my favorite parts of the company is that it's 100% remote. But my other favorite part is that I get to do all of the same work that I love doing as a scientist. And in fact, I get to do it on a broader sense rather than drilling down into exoplanetary debris disks. I've also worked on galaxy dynamics and fluid simulations on surfaces. And now I'm doing stellar physics, life simulation, and I'm really enjoying all of that. And yeah, that's me. How about you, Dan?
Hey, I'm Dan Dixon, and yeah, I recovering from a bit of a cold, feeling much better, but don't sound great. Yeah, I started at Purdue University in computer science. Absolutely disliked the project that they had. It was like recreate an ATM interface, like the most boring possible thing you could do. Switched to psychology. Ended up switching to Indiana University and studio art, and then ended up with just a Bachelor of General Studies. Still didn't know what I wanted to do. Then later realized video games were a legitimate career pursuit. Applied to a number of companies, ended up getting a job that brought me out to Seattle, and worked at a company for 2.5 years as an assistant producer. In the meantime, I had been working on a side project which was kind of the fourth iteration of a gravity simulator that I originally started working on back in high school. My dad had downloaded a very simple gravity simulator, and it didn't have CGA graphics, so like 4-color graphics, but it had like very, very simplistic options. And I wanted something that could do more. Anyway, I just kind of kept coming back to the idea. Anyway, I ended up moving on from that job. Thought, oh, this is now good enough to use as a portfolio piece. Let me, I'll put this up on the web. So maybe someone will hire me to do something else. One thing led to another. Was giving away for free. Moved to a name your own price model. That worked out pretty well for about a year. I was like making enough to make minimum credit card payments and rent. And then I got distribution on Steam and sold more copies in the first hour than I'd sold in the previous few months. It was totally wild. And then I was like, oh, I could hire people to help me work on this more, because this is my favorite thing. This is so interesting. So so I'm not the first person to do a gravity simulator, but I think I'm the first to like just never stop working on it. And then also a real focus on kind of the interface and making it fully interactive. So you're literally able to interact with it while it's running. So it's not a run and then visualize, or simulate and then visualize. You're simulating and visualizing all at the same time. And while it's running, you can click on and change any of the properties. So worked at a video game studio, worked in another smaller studio for a while, and then this took off, and I've been doing this now for the last 12 years, something like that. So yeah.
Which is a long time in the video game world, right?
That is a long time, yes. So yeah, I'm like, okay, everyone that's ever going to want to buy this thing has bought it, and then I'm going to wake up tomorrow and no one, and we're going to sell 0 copies, and that's never the case. There's always 100 plus people that show up and buy it every day. So yeah. I guess that's my story.
It's so interesting to hear a story that doesn't weave through postdocs, because it's a perspective that we don't hear very often. I mean, all of the people that I work with, they're either working on their PhD or they have their PhD. So this is such an opportunity to hear perspectives, and especially from Erika too, who has experience with both realms of science. So I have a question for Dan, and I have a question for Erika. So who wants to go first?
I'll go first.
Okay. The question for you is, can you talk a bit about the different aspects of academia versus your current job, and what's different, what's the same? You alluded to it in your introduction that you don't have to write grants, but you're still doing the science. But what else is there, and how does your day-to-day work environment differ from what you experienced when you were in academia?
Yeah, so I used to talk about the remote aspect of the job first in these conversations because it was so different from academia, but now we've all done it. So I think I can skip over that part. That was different than working in an office and having the sort of lunchtime and coffee break conversations with other scientists. And I missed that a little bit, but the flexibility is worth it for me. And we've all now learned how to have social interactions virtually anyway. So one thing that frustrated me about academia, and this is just very personal, is that I would finish a paper and I'd get it accepted and it would get published, and I just never felt done. I never felt like I'd accomplished anything. I was always second guessing my work. I guess that's the life of the theorist. The point is to second guess your work, but it felt very unsettled. And I liked having control of my own time and my own destiny, but I also wanted a little more direction on what I was supposed to be working on next. I almost feel bad saying that because we're supposed to like our self-directed, self-disciplined kind of work, but I wanted to be able to finish a task list and feel like I've been accomplished for the day, and I wasn't getting that from science. The other thing I wasn't getting from science is feeling like literally anyone was reading my papers besides the 5 people in the world that were in my subfield. So I wasn't sure how much I was actually helping society. I could certainly on grant proposals explain why my work was important for finding exoplanets and helping society, but it's kind of a long line to draw from what I was doing to that. And I wanted to work with the public more. I liked science education, and I liked that aspect that a lot of scientists and astronomers are drawn to, I think. So those were things I was looking for. So things I enjoy about my work now compared to that is that I do have a list of tasks, and I do those tasks and I feel accomplished at the end of the day. The list never ends, and I have a lot of independence because of the way our team works on what I want to work on next. So I still get that independence and self-direction, and I can work on what I want to work on within reason and with the cooperation of the team. And the other thing is that actual users get to lay eyes on what I work on every day. And I get to see their feedback if I want to. It's not required in my job that I have to read feedbacks. That's its own experience, but it's really nice. And I get to educate the public directly. I do some of the science education content writing stuff. I help with that a little bit on the team, and that's been really enjoyable for me. And I like feeling like I'm educating the public, and that I'm not just educating them, like I'm not just writing textbooks, I'm actually giving them a way to experience the scale and dynamics of space that is hard for any of us to just imagine in our heads, whereas playing this game in VR is just a fantastic intuitive experience of space. So day-to-day work, very similar to what I used to do. I sit down, I decide what tasks I'm going to work on. I do a bunch of coding, nothing works. I have to figure out why everything's broken. Or I'm reading research papers and trying to figure out how to turn equations into efficient code. So the very bare bones of it, very similar, which I like because I was an astronomer who liked coding, and I find that intellectually stimulating. So that part's similar, but the bigger picture stuff is different. I hope that answered your question.
Yeah, I mean, you can answer the questions however you want to answer them. This is just a conversation, but I like that the different framing and the different focus meant that you get a lot more enjoyment out of your work. So thank you. Dan, you're up. So the question that I have for you is, and I know that you and I have talked about this a little bit in our previous conversation, but for you, where did the inspiration for Universe Sandbox come from? Because you talked about having a gravity simulator, but this is so much more than that. So where did you get the idea to take science and put it into this kind of visual interactive format?
I mean, yeah, in some ways it was kind of iterative. But yeah, again, I started off with a gravity simulator, and that was actually quite easy. If you know if you know how to program, you can get a gravity simulator up and running in a weekend, right? Like it's like 10 lines of code. It's a couple of nested for loops. It's really straight multiplication, division. Like that's the easy part. And then and then it was like, okay, now let's make it so you can click on objects and select them and see the properties. And what'd be cool would be to add some trails. And then it was like, oh, actually now let's actually try to use real units. Let's try to actually model the solar system. So it was, initially I was, it was an object of mass 5 and distance 4, and so everything was just really small. And then okay, let's try to use real units. And then it's like, where can I get values for positions and velocities of planets? Oh, it turns out NASA has a website that will literally give you velocities and positions and a 3D coordinate system. This is perfect. And then, holy cow, you put those numbers in and it just works. Like you get circular orbits. It's like, wow, maybe they're not making these numbers up. Super cool. But then, I guess, and then it's like, oh, now like this is so much more interesting because it's real, like because now we're just not modeling random spheres that are moving around, which is still really interesting from gravity, where everything kind of pulls in everything else. You just get these really interesting interactions. Okay, now it's like, let's try Saturn's rings. Let's put some rings around Saturn at scale. Oh my God. And then you add Neptune next to that, and then it like rips those rings apart. And it's like, that's kind of what that's what would really happen if Neptune magically transported next to Saturn. And then, and so that, and then it was like, okay, now let's make, what's the next thing we could simulate? And it's just, and sure, we could make something up. Like, and I remember a conversation about, this is now before Erika came along, we were working on like, let's do some like very simplistic climate simulation on planets. And the individual working on it was like, we could just do something like what, if there's methane, it's like a 2x multiplier. And if there's this, it's that, let's just do something really simple and it'll be really interesting and fun to play with. And I'm like, sure, but if you're just making it up, if it's not real, then it's so much less, at least to me, it's so much less interesting. And at that point, it might as well just be like a kind of a glorified, screensaver, or just kind of like, I don't know, fractal design pattern, or I don't know, just some sort of, random cool visualization, which is very neat and interesting. And if it's interactive, that could still be a lot of fun to play around with. But, being able to interact with it and knowing that the results and that the data is based on reality, I think just is so much more interesting. So it kind of was this, there wasn't ever a grand vision to start a company or create this product where you could do all these crazy things. It, kind of was this, kind of slow iterative process. And then, and then I was like, yeah, but like we could fake it, but and that, gosh, that would be so much easier. But then it's just like, then it's kind of meaningless, or, it's still interesting and cool, but it wouldn't be as meaningful. So I suppose that's kind of where it came from. So yeah, and then, yeah, I guess I'm also still surprised that no one else has done this, because it now kind of, well, hindsight 2020, but it almost seems obvious, like, oh, gravity simulator plus heat simulation plus simplistic, I don't know, climate simulations. I don't know. Yeah, just I'm almost surprised that no one else has not taken a gravity simulator to this level before. So yeah, but because it at its core, it's a gravity simulator. That was really simple. So yeah, my background is not, no formal training in programming or science, really. I took like one astronomy class. Oh my gosh, I think I got a B in it. And it was like intro, and in the programming class I took, I got a C in that. Anyway, I also didn't like that, but anyway, I was not a good student. I don't know, I found it somewhat, anyway, no comment there. Yeah, the simulation is more interesting when it's true. Yeah.
I love that quote. That I might like take it and write it on an index card and put it on my wall so that I can have quotes of inspiration. It's good science motivation too. So, okay, question for both of you, and this one's going to be pretty fun. What is the coolest thing that you have either done yourself in Universe Sandbox or that users have done?
So I have an answer for this, because it's not necessarily the coolest thing I've learned about science from Universe Sandbox, but it's the first time I realized that I could learn about science from Universe Sandbox. I was rewriting our galaxy dynamics, which is one of the first things I did. And we don't have any self-gravity within the pieces of our galaxies, the different particles, because it's a lot of particles. But there is a way, if you've studied spiral galaxies, you know that there's a way to set up the orbits offset from each other that you can make these spiral density waves without even needing self-gravity, which is neat. So I was doing that, and I was showing that to our producer. His name is Rappo. And I was explaining that the whole gravity doesn't move together. Things are orbiting in and out of those spiral arms. And he said, oh, so if you took out a quadrant of the galaxy, that quadrant wouldn't just orbit with it? And I said, no, I think it would get filled in. And he said, well, why didn't you try it? Because you can just box select, you can like just drag and select one quadrant of the galaxy, delete it, and then we just let it run. And yeah, it filled in because it doesn't orbit as one piece, which I knew, but I'd never actually done before, because that's not something that I've ever made a simulation of before. And that was really striking to me, because it was the first time I realized that I could be actually learning stuff about real life, because I was still doing scientific simulation, even though I'm working on a video game now. Dan, do you have any ideas of
the
what
was the most interesting thing I've done, or the most interesting thing I've learned?
Either interpretation of the question. Just what is Yeah, what do you think is the coolest thing science-wise that you know of in Universe Sandbox? I'm trying to keep it as general as possible.
I mean, I already referenced. I mean, I think messing up Saturn's rings is probably one of my favorite. I've already mentioned it, but and because it's one of my, because it's my favorite thing. Like, yeah, Saturn's rings are in orbit, and often, I don't know that, I assume that most people don't have that conception of it, right? That they're literally just particles in orbit, and that and that like the middle of the ring is in geosynchronous orbit with the planet, and that the inner ring moves faster and the outer ring moves slower. I mean, I just assume most, so that was kind of something that, like, if you think about it, you might eventually come to that conclusion, but in actually simulating it, I thought was just fascinating. And
Jessica,
then it's just,
can I screen share? Because I could show you what he's talking about specifically.
well, yeah, sure, yeah.
Oh my gosh, yes.
All right, so here's, can you see my screen? It's Saturn and Neptune, yeah. Yeah, so this is Dan's favorite simulation.
Oh yeah, with Neptune ripping it apart, yeah. If you surface lock onto Saturn, then you can see kind of how the rings are geosynchronous. Although getting it ripped apart also kind of messes that up, but
it's just a really pretty game.
Anyway, yeah.
I gotta say, this happens a lot faster than I thought it would.
Yeah, it's about a 20 minute per second time step.
Wow.
Yeah, if you run that again without Neptune, then you could see maybe you can see the ring motion better.
Sorry, I if we screen share too much, we'll just end up showing you guys.
Fair enough, yeah.
But I figured you should at least see what we're talking about.
There we go. Yeah, so there's how, so now the motion of the camera is locked to the rotation of the planet itself. And so you can see that the inside ring is moving faster and the outside ring is moving slower. And then somewhere in the middle is moving at the same speed as the rotation of the planet. Anyway, I think that's super fascinating and just super cool. And then again, yeah, ripping apart Saturn's rings. Oh my gosh, that is like the most satisfying thing. I've done that over 1,000 times, although maybe it's 2,000 now. I don't know, like just thousands, like literally hundreds and hundreds and hundreds of times, and it never gets old. So it's, yeah, I mean, yeah, just destruction at that level is like kind of amazing and beautiful, but especially when there's no people involved.
So there's definitely a lot of destruction in the game, and I know Dan loves the collisions in the game too. But one thing that we've noticed our users are really obsessed with is terraforming. So they're always trying to take Mars, add water, add an atmosphere, and make it so that the water will stay liquid and it'll stay at the right temperatures and things. And so one thing we've been working on for the past couple of years, definitely since I came on board, is give them more and more tools to do that, which means now I'm working on chemistry of all things, which a dynamics theorist is not what I ever thought I'd be doing with my life, but we're trying to give them more abilities to do that. And it can be really frustrating for them because it actually is kind of difficult to terraform Mars. And rather than making it easy for them, like Dan said, that wouldn't be as satisfying. We're trying to make it as realistic as possible.
Oh, I guess another interesting thing that like I learned from Universe Sandbox was if you, let's see, how is that? If the entire planet were to freeze over and everything goes white, now the albedo is higher and it takes much more to like unfreeze it. So like it's not just, you don't just, you know, if you move Earth out of where it is and it froze over and then you move it back into the same orbit, it doesn't unfreeze. Or something like that. So,
yeah, we added this phase changes on the surface, and the users got mad because they would delete the sun, and then they'd say, "Why isn't there the Earth's ocean freezing over?" And I had to sit there and do the actual math. Like I wrote it out in a blog post for them, explaining that it takes roughly 100 years for that much water to freeze at absolute zero. And I had never needed to know that before, but I had to do it to prove we didn't have a bug in the game. So that was interesting.
That the oceans take longer to freeze.
That the oceans take longer, yeah, because we were doing it. We weren't just jumping to steady state. We were actually doing it based on the energy transfer.
That is so cool. And I suppose I've never thought about that. Like, what would happen if the sun just magically disappeared one day? And
yeah.
Well, one of the challenges of the software is that the users can basically ask questions that no astronomer would ever reasonably need to think about.
Yeah, Dan always asks me like, okay, but what would really happen in real life? And I have to say, I don't know, Dan, no one's ever lasered Jupiter before. I can't tell you what would happen.
Right. But okay, but like, but but what would happen?
Yeah.
Right. Yeah. I know no one has, but let's think about it. I don't know.
Yeah.
So.
Now, we actually have a few exoplanet people in the room, and I wonder, can you talk about anything that you've done either recently or plans to do so in the future regarding exoplanets specifically?
So we have, we use Hannah Rain's Open Exoplanet Catalog to build our database. We have a built-in database that has like 50,000 solar system objects and the solar system planets, and however many exoplanets we're up to, like 5,000, right? And a fair amount of stars. We have a set of like the 100 closest and the 100 brightest stars, and then all of the stars we could pull out of Simbad from the exoplanet catalog. Definitely not complete in terms of stars, but you can open up and add basically any exoplanet system. We also have a habitable zone calculator, so you can flip that on and see which planets are orbiting in the habitable zone, which is pretty interesting. One thing that we've been talking about that's going to take a little longer is we can do all this destruction. We have fragmentation built in. We don't do planet formation yet, because if anyone's worked on planet formation, that takes more than just an n-body model, which is what we're built on. It takes some kind of SPH, and we've talked a lot about that. But this is something that people are really interested in too, is forming planets out of a disk.
SPH is fluid dynamic simulation of some kind. Yeah.
And one thing that we can do, which I find interesting because this is what my work was on, I worked on finding signposts of exoplanets in debris disk morphology, and you can do that. That's just n-body. You can, so morphology is the shape of the disk, and any weird gaps or asymmetries in the disk, you can figure out where the planets are. You can simulate that in Universe Sandbox. We do work at slightly different timescales than most exoplanet physicists are working on, because we are usually working at orbital timescales. The time step of the simulation is sort of limited by certain things. So in terms of timescale, that's one of the biggest differences between the exoplanet work I used to do, where I was running at these super high timescales and running it on the NASA supercomputers without watching it run, right? And then looking at the data afterwards. Now we're trying to run it on someone's laptop or phone even, and we're trying to simulate everything at the same time, surface simulation and such. And so, so that's slightly different, but you can do a lot of interesting exoplanet stuff, and we very much benefit from the Open Exoplanet Catalog. I wish that all of the different parts of astronomy were as good with their data as Hannah has been with the Exoplanet Catalog. The astronomers on the team are often having to explain to the non-astronomers on the team why the data is so bad, and it's because, as you all know, everyone has a different way of storing their data, and you have to make them all work together.
Dan, anything to add?
I was also, yes. I mean, like when I worked on this, so originally, yes, the very first version of Universe Sandbox I wrote basically myself. And again, it was mostly just a gravity simulator, and it was spheres with just textures on them. So there's no surface simulation, very simple heat model, like, again, a few lines of code. So, but yeah, finding data and like sorting through it was all surprisingly, I'm like, yeah, I was also surprised that the data wasn't more, that there wasn't just some sort of like nice, simple database where you could look up stars that was all clean, and I don't know. So yeah, but I'll just not in agreement too. I'm surprised that it's not more organized. But
the other thing that's been annoying to me in the past few years, since I'm the one managing our database, is that my former friend and colleague, Scott Shepard, keeps discovering new moons of Saturn and Jupiter, and I have to keep going in and putting more in the database. So maybe Scott could take a vacation.
Have you heard about exomoons?
Yeah, well, I haven't been telling Dan about exomoons because it means we're gonna have to add.
Let's add them. Let's do it.
We're gonna have to update the database structure to be able to add moons to exoplanets. Yeah.
Oh
yeah, we don't.
No, we don't have that yet because they hadn't discovered any yet. Yeah.
All the moons assume that they're in our solar system today. Yeah. I mean, that could be.
Thanks, Jessica.
I'm sorry.
How many do they? Well, yeah, what's the number? How many have they discovered?
I think it's only 4 or 5. Somebody else, if you know, maybe you should jump in and say it.
Yeah,
but
what's the confirmed number? Because we've been talking about exoplanets for a little while, but they kept disappearing out of the data.
Fair. I think it's only 4 that have been confirmed. I know 1 definitely, and then I think there were like 2 or 3 more recently. So that's about the extent of my knowledge. So I guess I do want to remind the audience, like, please, if you have questions, feel free to write them in the chat or raise your hand. I'm trying very hard not to dominate this conversation, so please feel free to jump in whenever you have something that you want to know about. But in the meantime, I have a whole list of other questions. And Erika, if I could go back to you and ask you, what was it like to transition from academia into this more like video game focused industry? What was that like to make that switch, either like mentally? I mean, you've talked about your job too, but like what else changed?
Yeah, so I was worried about losing, I don't know, there's a certain ego identity attached to being like a scientist, right? And I was worried about losing that because everyone loves it when they meet you and you say you're an astronomer. People go nuts. I used to be a mathematician and nobody wanted to talk to me on an airplane if I said I was a mathematician. But if you say you're an astronomer, people love talking about that. And I worried about losing that. But it turns out I can still call myself an astronomer. Dan lets me keep it in my job title. And I'm actually still co-authoring papers. So it wasn't as much of a like clean cut as everyone told me it was going to be, which has been nice for me. I was a little worried, Dan knows this, I was a little worried about the culture of the tech world and the games industry. This wasn't that long after Gamergate that I joined the team, and I had not been a gamer, but I knew that gamers could be awful people. And so, and I knew that the tech industry in terms of careers could be really harsh and bad work balance, et cetera, et cetera. And so I was nervous about that. But interviewing with Dan and our producer relieved a lot of my worries. And then it turned out everyone was super nice on the team, which I think does not mean that I was wrong about the industry, just that, you know, you can find good people within the industry. And that's been great. Dan is very protective of us as a team when they do hiring. And that's been nice. I also have enjoyed interacting a little bit with our user base, but I also enjoy that it's not my job to interact with our user base. That was mostly the main cultural shift that I was concerned about. And I still interact with enough academics that I still get this sort of academic interaction that I enjoy socially.
So you mentioned this before we started recording, so I'm going to ask you to repeat yourself, but do you get to go to scientific conferences?
Oh, I actually talked Dan and a few others from our team into going to AAS a couple of years ago. We had a booth in the exhibit hall in Seattle. I forget which year that was, before the pandemic, obviously. And that was great. I do not go to scientific conferences for my job, but my job involves a lot of flexibility in terms of my time and interests. And I run a nonprofit about space ethics on the side and wrote a book on the side, which is not something I could have done if I had stayed in academia, I think. And I go to conferences for that because when you work remotely, you can travel a lot more. You know, there's a lot of communication between me and Dan about time and travels and things like that, but it's been really nice. I've enjoyed that. So I am still going to conferences. It's just about my own interests instead of my job.
We have a question from Bradley who asks, how does job stability and compensation compare to academia?
Yeah, so I guess I'll answer that one too. Dan pays me well. He gives me a lot of raises. I'm pretty sure you can make a ton more money outside of academia as a coder than you can inside academia as just a blanket statement. I'm pretty sure, and I think Dan would agree, that I could be making a ton more money doing something else in the tech world as a programmer than I'm making for him. But I don't mind because it's worth it for me to have the flexibility in terms of time and location, and because I love the work so much, and I wouldn't if I was just working for, you know, Google or whatever. Stability is a really interesting question. And I love talking about, I think I mentioned this to you, Jessica. I love talking about this to scientists in particular, because I was really worried about leaving the academic path, because you start as an undergrad and they lay it all out for you, right? You're going to go to grad school, you're going to get a PhD, you're going to do 2 to 3 postdocs, and then you're going to get a tenure track position, and then you'll be this professor or that professor, and then you'll get tenure, you'll be a full professor. That is the way it's done. If you fail at any of those steps, especially the postdocs, right? So if your postdoc is running out, or you're at the end of your PhD funding, and you don't get a job in that job cycle, you're done, right? There's no staying. You can't like take a year off and go back in. Everyone tells you, you got to go get another job somewhere. And that is something I had never thought about, because we talk so much about job stability with tenure. And then I go off to this team in industry, and our assistant producer, I was talking to him, Rappo, about his career path. And he had worked for a number of companies where the company failed while he was working there. And I said, oh, that sounds terrifying, that the company you're working for can just go under, and that doesn't really happen at universities. And he said, oh yeah, but I mean, another company swoops in and hires everyone that just got laid off. Like, you are always going to find another job. And so it's not like you have to leave the industry. And I had never realized that. It was an excellent point, and that's true of the tech world in general, that your position is a lot more tenuous, but your career is a lot more stable, because there's not these failure points where you have just fallen out of the industry and you can't get back in. And I prefer it that way. It's still kind of terrifying to me. I don't want this company to go under, but I think that it lets you take more risks. And I think that academics would take more risks and see more reward if we felt like we could, if we felt like we weren't trying to just get the next job in 2 years. So that's a great question. And it's very different out here.
Yeah, I mean, I guess I would add to that. Video games and the video game industry in general is pretty crazy. And as far as like indie studios, they come and go, and most independent video games that are released don't make any money or barely sell any copies. And so, I've been I feel super lucky that this title has resonated and continues to sell. I mean, now, the original version was launched on my website in 2008. And on Steam in 2011, and it's sold. It is sold. I think at the lowest point, the original sold like 30 copies a day, and the newest version averages several hundred copies a day. There's never been a day where it's sold 0 since 2011. There's not been a single day that's gone by where it's sold 0 copies, right? It's just wild. So,
but even if it had flopped, right? Like if it hadn't taken off, you would have found another job, right? You're
oh yeah,
employed, right?
I could, yeah. If this didn't work out for whatever reason, some other, I could, yeah, something tech, something video games. I could almost certainly get hired doing something else. So.
I had always heard that physics PhDs are extremely employable out here. And it's true. It's scary because usually a lot of people end up in industry because they fail to get a job in academia at some point along the way. And so it feels like a failure and that you're not employable at all. But it turns out like there's a lot of very different things that you could do out here if you can code, if you can write about technical topics in a way that people can read. Like there's a lot of jobs out here. It's a bigger world than academia.
Thank you both for being here today to show us a part of that bigger world. So I think it might be a good time to transition more into that workshop session, and trying to pull up the email where I had all those good ideas. Haha, here we are. All right, so attendees, no breakout rooms, please don't panic, but we are going to try for a more interactive portion now. So just want you to pause for a few minutes to think of your science and ask yourselves which parts might be good to delegate of sorts. Like what part, if you were just teaching somebody how to do the science, what are some tutorials that you would start giving them, and where would they start learning about your science? So let's just take a minute and we'll think about that. And again, if you still have questions, we can still ask questions, but otherwise just think of where you would start. Okay, we're back. Does anybody want to share a little bit about their research and where they might begin with some kind of tutorial to introduce a new user to science? I can go first.
I was going to say, since there's only 9 of you, I would be interested to just hear briefly what each of you are working on.
Oh, that's a good point too. If you'd like to, if you feel more comfortable typing, then feel free to type it in the chat. But yeah, what are you working on? Or maybe what would you like to work on, or a new project that you're excited about starting?
Hey, I can chip in. This is Srinivas. I'm a postdoc at JPL. I'm not a scientist. I'm a hardware engineer. Basically, I build instruments for Earth science, planetary science, and other whatever NASA does. So I'm entering an intern right now, and then yeah, like one thing I have a hard time is trying to get him to the same level as we are. Which I mean, obviously would take time, but also just as an entry level. So I use a lot of these softwares to design instruments. CAD softwares, which are very advanced, and I have been learning it since my undergrad days, and I still don't like calling myself an expert on any of those. I mean, all these companies do have tutorials, videos, PDFs that help someone to get into it, but still I think it is you need to be at a certain level to even get started on those tutorials. Otherwise, if you just see them, it feels like either you're not getting anything at all, or you're completely lost. So I always have a hard time figuring out how to get someone at an entry level to do something useful for us, and also at the same time that they can learn something from the experience as an intern or as a co-op or something like that.
So it sounds like someone needs to make some more basic level tutorials for that CAD software.
Yeah, that would, if that's possible. So
great, thank you.
That was a really good point of the steep learning curve in a lot of different sciences, especially when there's something very hands-on.
One thing I've discovered is that you can teach yourself, I mean, we all know this, we're all self-taught programmers, most of us who work in science. It's pretty easy to teach yourself how to code, but every time you switch to a new language, it's all the rest of it, setting up your environment, which compilers do you need, where do the files go? That's always my stumbling block. I can sit down and type the code out, but setting up the new workflow is something that there's not a lot of tutorials about. And I was lucky in this project to have a team that could walk me through it, but scientists don't always have that opportunity.
Does anyone else want to share a possible tutorial for their work?
Hi, I can try and share. So hi, my name is Zaid. I'm a grad student at UC San Diego. My background is in like biology and computer science, but I'm studying right now how we can use like the science of light to make low-cost medical diagnostic tools for a bunch of diseases. So like, I guess in our case, tutorials will be more like, how does light and matter interact, and what do those interactions, result in? So things like that, I think, kind of help people understand, what's going on, because like we see light, but we don't understand, or we don't see the interactions, but just the result that comes from those interactions. So that kind of tutorial would help for sure.
That sounds like very cool research, Zaid. Thank you.
That's really interesting too, is coming to it from a biology perspective, is that light matter interaction is such a physics thing, and biology is so much further on the other end of the applied scale. Sorry, I'm trying not to be a snob about that, but yeah, biologists often have to come back to the physics and chemistry level, right? And you need the basic understandings of those mechanisms before you could actually do your work.
Oh yeah, exactly. That's something our entire lab struggles with. We're all learning how to go through.
Is there one more person out there?
Well, I can go if no one else wants to. My name is Lillian, and I am a geophysics PhD student, and I work on the tidal deformation of icy moons, the surface deformation, specifically strike slip faulting. And in order to explain these things at conferences and stuff, I've just, I also have a background in media design. So I have another bachelor degree in media design. So I used Cinema 4D to make my own animations about how things orbit around each other and, deform the surface and things like that, and then integrate my calculations. I mean, my plots, the plots from my calculations into these visualizations. But if there's, this tool sounds super interesting, and I'm probably going to get it because I want to see what I can do with it to explain my research to other people.
Lillian, that background sounds so useful, because one of the things I definitely did not have and still don't have is a good grasp on graphics at all, graphic design, the technical aspects of it. And I think it's so helpful to even just be able to sit down and sketch out what you're trying to explain to someone. So that sounds really helpful.
The issue is then if people find out in academia, you're like, oh, can you do this for me? Can you, oh, I have this website I'm working on, blah, 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 so.
That's fair.
I'm always doing other things too. And I'm like, okay, thank you. I would like to earn some money for this too. It's not a free skill, But anyway, I'm happy otherwise.
Design and art are often underappreciated and underpaid.
Yes, totally. Mm-hmm.
Tidal deformation of icy moons. That sounds really cool.
I'm
like, oh yeah, I want to let's see it stretch. So yeah, we're talking about, well, no promises, but like one of the next features we're talking about it. So all of our planets are spherical all the time, and we're talking about adding the ability for them to deform from.
We do some tidal calculations, and our physics guy just added spin fragmentation, where if you spin something up fast enough, it comes apart in a plane of fragments, which looks really cool, as cool as you're imagining it. But it still goes from sphere to flat. And, we have these icy moons and they don't really respond correctly to that. So
I have a challenge for you then. Can you add internal parameters?
Like what?
Like the rigidity, like the how do I say this? The density, I mean, the layers, you have an icy layer, top layer that is rigid in this and this, and then you have an internal ocean, and then you have a core that is made out of rock, silicates, and things like that. So I'm working with another, it's an open code, but the problem is the code is kind of discontinued because it doesn't work with the new Fortran compilers since 2018. So I'm working on old laptops trying to get the code working and stuff. But it's called SAT stress. So that calculates stresses, the stress tensor components at least. And then
might go check that out. Yeah.
Yes, please do. So
this is another thing that used to frustrate me about as an academic who was very into the computational part of it. And this is a very common theme, is that maintaining and improving the usability of code in our fields is not rewarded or incentivized at all in our fields, right? And people have talked about, if you're just trying to get publications, I was told as a grad student not to make my code publicly available, because then people were going to always be bugging me about using it and fixing it, and I wasn't going to get anything out of that. It's very frustrating because all this stuff is out there. And why do we have to reinvent the wheel every time someone new starts on a project? So I'm really glad that you have some open source code.
Yeah, so that's on GitHub if you guys want to go check it out. But the problems are, well, there's a few things. There's an issue there. And they do have a GUI, which is great to use, but half of it doesn't really work exactly. But that
can you type the name of it into the chat?
Yes, sure.
Or share the GitHub link.
Oh, yeah. Thank
you. Something else as a non-academic that surprised me is that the paper is more important than the code. But isn't the program that run, isn't the program so much more interesting than a written description of the program? So yeah.
I think this is a reflection of metrics that we use for things like hiring and promotion in academia, where the most important deliverable does seem to be the paper or the publication. And you're right, because it doesn't incentivize us to make code very easily accessible, although I think there are rules now that we have to put a lot of stuff up on GitHub. NASA has a data repository now, and every, at least in ROSES, which is the research opportunities in space and earth sciences. I think I have that acronym right. A lot of these programs within ROSES require a data management plan now, because we are starting to recognize how important it is to have data available and organized and usable. So like, things are changing. They're just changing very, very slowly. So if there are NASA management people and I said something wrong, please correct me. I wonder if I could ask one more question. Ooh.
Thanks, Lily.
Could I ask one more question then related to graphics? Because I'm very curious how the graphics team interfaces with the coding team versus the science team. So what does that look like? Oh, Vice Navas, thank you for coming.
We have a couple guys who work on graphics. One of them has been with you since the start, Dan, right? George
Yeah,
is one of your first hires.
10 years now. So
Yeah.
well, so yeah, the original version I started working on like 2006 part-time, released it on my website 2008, and then launched that on Steam in 2011. And then at the end of 2011, I hired the first two people on the team, Chris and George, both based in Germany, and they've been with me. They're still on the team and have just done amazing work. And then now the team is up to 12 people altogether. So
it's been really interesting for me to work with the graphics people, because that's not something that was ever a thing when I was doing science, right? Like I had to make my own plots. That was about it. Once I wrote a paper about beta pictoris that the NASA Office of Science Visualizations, whatever they made a little video out of it. So they actually did some nice graphics work and made a nice video. But that was like the most I'd ever done. But now working more closely with the graphics team has been really interesting. So usually that's in the form of, I'll add a new simulation feature and I'll say, hey, I have this new thing I want to be able to visualize. Can you guys help me make it look pretty on the screen? Can you let it affect the rendering of a planet that we already have? Or they will come to me and say, hey, we are trying to make the glow of the stars more standardized, or the black body color of the star better represent reality, or we have these little gas clouds and they wanted the density of those clouds to actually be reflected in the opacity that you could see. And so they'll come to us and say, can someone on the physics team like give this your okay that this is scientifically feasible, which has been really interesting for me. And a lot of times we end up having a conversation where we say, okay, this thing that we want to draw is something that we cannot simulate or that we don't know in real life. So we are making the decision that we're going to choose the aesthetically pleasing version of it because there is no scientifically like real thing that we can base it on. So we'll do it aesthetically instead. Or we'll say, this is something that you can't visualize at all. Like you can't see the difference between these two things. So we might as well make it interesting looking. We have a few different view modes where you can make it look totally realistic, which means you can't see a lot of stuff, or you could have it more enhanced or make it so the objects are always visible and you can choose between that. But it's been interesting to me to always have to go back to that conversation of, is this a scientifically real thing we want to visualize, or are we just going to say we're going to make it look good? Because we're always trying to find that balance.
Yeah, the graphics team also, I guess would add, they're basically coders also. Like in a typical video game studio, you'll have kind of the programming team, and then you'll have like the graphics team, and they'll like be creating like 3D models. But then, we have almost everyone on our team is a developer, which is interesting. So and slightly unusual versus say as is typical in like the video game industry.
And they all are getting pretty good at astronomy too. Like today, I was reviewing something by one of our graphics guys. He was replacing the texture, the image that we use for the surface of Titan. he replaced ours with a better version because he was getting better data from NASA. And I noticed it went from being orange to black and white. And I said, should it be black and white? Titan looks orange when I Google up, like, show me a Huygens picture of Titan. And we had a conversation about, okay, well, is it orange? Is there actually surface orange, or is it made up of water and rock and it looks orange in these pictures because the atmosphere is orange? And we had to have a little conversation about that, because in real life, doesn't matter, the pictures are always going to be orange. In our game, the user can turn off the atmosphere and we need to know what color to show on the surface. And so the graphics guys do a lot of, research on NASA images and spacecraft because of that. And they know a lot about optics and the human eye, more than I do about like what the human eye would actually be able to perceive.
Oh, that is a really cool aspect of science I hadn't even considered. Of course, there's people with color blindness, and I know that in our presentations as scientists, we tend to consider that, but the actual optics of the human eye.
Yeah, because Dan's always going to come in and say, if you were in a spaceship looking at this, what would it look like in real life? And most of what I work with is observations, which is highly exposed, etc., and not necessarily what the human eye sees.
Well, and then on a broader level, like, if you look at the solar system from a distance, you can't see anything. So we have like a setting that makes everything little tiny dots so you can see something, right? But then you can also set that realistic, and then you go back to only being able to see the sun. So yeah, but it is a balancing this, what is scientifically true and what is interesting, or because if you look at the solar system, you don't see anything, like that's just uninteresting. So trails also actually are a really useful way of like showing where an object is without actually showing the object. So, but that's also like kind of not a real thing, but anyway, yeah. So it's
usability versus realism is a balance.
Yeah. So what a fun problem too. So
yeah.
So I'm going to use this opportunity now to ask our participants for another little thought experiment, to say what parts of your science do you think are the most easily visualized, and maybe not even visualized? Is there something that would do very well as a tactile or a touch kind of interaction that you could have with a potential user, or maybe something audible too, like what does space sound like? And I don't know if this is possible, but what does space smell like? Like if you went to Titan and if you could breathe, what would that air smell like? And if there are any kinds of sensory stimuli that you could pull out of your research, and try to think of what those might be and how you might implement them, and to make that science even more accessible. Yes, exactly. Smell-o-vision. All right, and if anybody has any ideas that they'd like to share with the group, please feel free to unmute yourselves and share it. I can say that I'm somebody who, like Lillian, I studied ocean worlds for my dissertation, and I've been progressing to the outer solar system, like farther and farther away from the sun. But one of the things that I've been working on recently is cryovolcanism. So anytime I'm like, oh, I need to describe science, I go to cryovolcanism. And I think that touching something very cold, not to the point where you get burned from it, but touching something kind of cold and goopy might be really cool as a part of like a science engagement.
Can you do one of those like middle school science fair volcano tabletop experiments with something cold instead of baking soda and vinegar?
I mean, I never even did the traditional volcano, so I should do both. That could be a cool video at some point. Like, what? TikTok sounds like the perfect arena for that. I have no idea what cryo lava would smell like. No clue.
People always want to know what space smells like. That's one of the things I ask astronauts a lot about the ISS.
I once, this is kind of cool. So when I was a postdoc at ASU, I was helping out with a public event day, and some group within our School of Earth and Space Exploration had chapsticks that, based on the composition of some galaxy, and I forget which one, that it would have this kind of scent and flavor profile. So we were giving out chapsticks that were supposed to like smell like this galaxy. And I always think about that of like, wow, that kind of blew my mind when, like, what does space smell like? Here, have a chapstick, you know.
That is interesting because it is one of the ways that macroscopically in our daily lives we understand and interact with composition, chemical compositions, is through taste and smell. We just don't think of it that way.
Mm-hmm.
So while everyone's thinking, I'll mention that on the team, we've been interested in using audio to convey scientific information. We have gone back and forth with that a little bit. And this is another example of like usability versus realism. Obviously, there's no sound in space. But if you added sound, you can add an extra dimension of conveying scientific information. And so then you can ask, you know, how could you use sound, the frequency of sound, et cetera, to convey a stellar spectrum, for example, even while you're not looking at it, it's behind you in the simulation. And interesting questions like that, which I find really interesting because it was stuff I hadn't thought about before.
Yeah, what does Rigel sound like versus the sun, for example? So, which, yeah, and I mean, they don't really make any sounds, but yeah, and you know, when you like bombard the Earth with asteroids, you know, like that dull thump is so satisfying, even if that's not at all how it would really be. So,
but I've seen this before in science of people trying to add audio as a way to do scientific visualization, which is a weird way to say it. I've seen like cosmic rays portrayed with sound, and in fact, I even tried, I think, doing a debris disk simulation with sound, which my advisor had to do in grad school. Which is, again, just adding another dimension. But yeah, I keep talking. Is there anyone else have any thoughts about their own work? Everyone's gone for a cup of coffee.
Yeah, we're such a small group that maybe everyone would be comfortable ending it a bit early. I might say we go for another 5 minutes just to allow for last minute questions, last minute thoughts, and then some sign out details that I will say. But that sounds good to you. Feel free to like thumbs up in the chat or with the little reaction bar at the bottom. So I do want to go back to talk about terraforming a little bit, only because it feels like we touched on it, but what more? I'm sorry, I know this is a tricky question, but like what more are you looking into at Universe Sandbox to make terraforming more realistic?
Well, they hired me to do life simulation 4 years ago, and we haven't put that in the game yet. And part of the reason that's not in the game yet is because we needed more data. And one thing we were missing is composition, more materials. So we simulate water and how it moves across the surface. I've been working on that for the past few years. But we also, you know, if you want to really know whether you have terraformed a place enough to be able to grow crops, you need to know what the atmosphere composition is. And so that's something like now we have to add nitrogen and oxygen, carbon dioxide, because that's going to determine how well your plants grow or die and such. And so that's been a big thing that I've been working on. But just phase changes and pressure and such in general are have been interesting to add. That yeah, you can throw a bunch of liquid water down on the surface of Mars and make sure it's the right temperature that it doesn't freeze. But if you don't have an atmosphere, it's all going to evaporate away really fast anyway, which could be frustrating for the users. But we don't even simulate radiation. I don't think it's necessary to do an initial terraforming simulation, but if you really want to get into the sci-fi of how would we terraform Mars, you have to include radiation protection as well. Dan wants to be able to reproduce the comet that killed the dinosaurs, which means I have to be able to reproduce the dinosaurs.
Yeah, that is kind of the grand vision for, and without it being a scripted event, right? So that that you'd have, very simplistic. Well, or maybe maybe something that we'll get to more quickly is like what the oxidization event, where so you might be able to have two kinds of life forms on the planet, one that uses oxygen, puts out carbon dioxide, and the reverse, and then that will then change the balance of the atmosphere with these kind of the distribution of creatures on the planet. Again, very simplistic. You can't actually see the creatures, but the creatures are kind of going to be represented in a grid where each grid cell has a certain amount of water, a certain amount of different materials, kind of, and certain like a biomass of creature A and creature B. They can spread to other cells. And then you could like remove all the oxygen or add a bunch of oxygen and devastate one or the other. So,
or very carefully try to tend a garden that your life can live in, which is the hardest. Yes.
Yeah, or that. So
that's actually led to another interesting user experience question that I realized, which is as I've talked to Dan about this stuff, is that we can visualize two ends of the life spectrum on the surface from space, on the surface of a planet. I can show you vegetation because you can see from space where the vegetation is alive and not alive. And I can show you intelligent life because we draw city lights on the night side of a planet. Anything in between, including the dinosaurs, you can't see from space. So then once we get to that point, we'll have to come up with another way to visualize that data.
You've brought up such good points that even on Earth, there are so many important events within Earth's history, like the multiple snowball Earth events, the Great Oxidation Event, at least 5 major mass extinctions, and these are just the ones that we know of, including the KPG extinction event, the asteroid that made the Chicxulub crater. So that's actually one of my favorite science topics. So I don't want to talk too much about it because I could just keep going for another hour. But I want to open the floor one last time to see if anybody has any questions, or if you two have any questions for us.
I guess people don't have to answer this, but as a takeaway question, I liked the one that you had on your email list, Jessica, which is I'm going to rephrase it in my words. If you had some other team of video game programmers working on this, what kind of game that demonstrates your particular field of science could you imagine? Whether it's like ours, where it's very realistic and you can interact with it, or even just a more diagrammatic cartoon toy model version of it. What would be fun about it? What would be super boring about it because you can't see anything? How would you make it interactive? I think it's a fun exercise, even if you're not trying to make a video game about your science. And thank you, Mike, who said you'll tell teachers about it. We have been working with some teachers at various levels who use Universe Sandbox in the classroom. So feel free to have them get in touch with us. I think I can say.
Yeah, always interested to know what we could add to it that would make it more useful in the classroom. Because I see that, and being able to have fun with it. I like they're not in conflict, right? Like it can all be the same thing, where it can be a really great great classroom tool, but also something that a random user can just sit down and play around with and have a really good time with. Or crazy people on YouTube can make videos that are just with ridiculous premises and that attract a lot of views.
I replaced the sun with a black hole and this happened.
Exactly.
You'll never believe what happened.
I would want to see that video, actually.
There's some good, I think I'm quoting a real one, actually.
Yeah, I think you are too, yeah. So,
yeah.
Although, admittedly, that's actually not that interesting, because if it's a black hole of the same mass of the sun, nothing happens, and we're not, I don't know. Although then that then like raises the question: would there be like weird radiation from that we're not simulating? Like, yeah, well, it would go dark, right? There'd be no light, so
Right, so the
Earth would
everything
freeze
get cold.
over.
Yeah, but the orbits stay the same. Yeah,
Yeah. So
we actually have a demo of that because someone made a YouTube video about it.
I will have to check that out then. All right.
Yeah.
So
I guess as a final comment there, just yeah, YouTube has been we've done, yeah, the other wild thing is that we've done almost no marketing as far as like spending money on that or anything, and it's been almost entirely, well, word of mouth and yeah, YouTube kind of creators making videos about our product has been the kind of has just been delightful and has been a really great source of, well, I think new users discovering the product and buying it. So, and then I'll also just shout out to the entire team that none of this would have been possible without them. Oh my gosh, they're so great. I am blown away by what we've been able to make over the last 10 years. Super cool, very grateful. So.
See, not everyone in the tech world is mean. Some of them are very nice.
Yeah, thanks.
Oh, quick question from Lillian, who wants to know, can we export .obj out of the Universe Sandbox?
What's .obj?
Is that like a 3D? Yeah, it's a 3D format, right? Like a 3D object format?
Yes, exactly.
No.
So you
Although, yeah, I'm curious what you're.
Sorry?
Yeah, so you're wanting to like set up a situation in Universe Sandbox and then export that out and to open in a 3D modeling program? Is that the
Yes,
idea?
exactly. So because I've been also, well, that was a few years ago now also, I've done augmented reality things for basically you can point your iPhone at something and, you know, a planet will appear and you can look at the planet from all sides in 3D, kind of like Pokemon. So, so you can export, if you have object files, you can export it into Augment and then have an augmented device kind of thing. So,
But Universe Sandbox does natively support VR, so you can.
okay.
You can already look at it in 3D, but yeah, exporting planet textures is on our list of things to do.
Mm-hmm.
I guess I'd be a little more curious about the specific. Are you just wanting to export a single planet or like a full system with animation? I don't know, like some of that.
Yeah, that would be, my vision would be to have like a whole scene exported, you know, and then look at that animation from all sides, basically, instead of just a planetary body that you can have on an augment or something. You can just have the whole scene and look at it. And if it plays out, that would be even better.
Yeah.
Well, the answer is no, but now you've got us thinking about it.
Okay,
well,
great.
yeah, I mean, anything is possible with enough time and energy.
That
would be possible. It would be possible to do. I suspect that's going to be just really low on the priority list as far like the number of people who have requested that or the number of like the use case for that is pretty low.
But if you want to send us a wish list, please feel free.
Oh, of course.
We're always looking for feedback.
All right.
We just don't make any promises.
Would you two be willing to put your emails in the chat, or let me send out your emails with the follow-up email that I'll send about this?
Sure.
I'll just put mine in the chat. Probably figure out ours from each other's email addresses.
Cool. Well, thank you everybody for coming, for being here, and thank you to Erika and to Dan for your time, your effort, and these fascinating answers that you've given. I feel like, you know, I know that you and I, we've talked before, but I still learned a lot. So thank you again. I will say to everybody here that if you are attending either Exoplanets 4 or AbSciCon within the next month, feel free to shoot me an email and just you know, or if you see me walking around, feel free to say hi. I'd like to meet all of you in person. And well, I guess that's it for me. Other than that, everybody take care. Have a really great day. And thank you all for being here.
Thank you very much. This was a lot of fun.
Thanks, Jessica.
Cheers.
Thanks.